Hi there, my name is Cronenwett. Today we're going to make a set of insulated lines for flying control line models with down-the-line electronic controls. Now this could be Clancy Arnold's down-the-line system, Bill Young, servo driver, or the JRDSC radios, or any of the multiple systems that are out there where you have to send the signal and ground down the flying lines. Now the reason why you're seeing this connector right here is because that connector is used to transmit the signal coming from your device down the two flying lines. So it's hard to see, but these lines are nylon coated and they were originally designed for saltwater fishing. Now, American Fishing Wire makes a product called Surflon. Now, I haven't purchased this for a while, but Surflon has a thin nylon coating, which kind of makes them insulated. You can rub these two lines together, and they're not touching. It's nylon. It's nylon touching nylon. So. Which works great for us. They're durable, and these lines don't touch at all. And if you're using down-the-line electronic controls, the lines have to be insulated. If the lines touch for any reason, the system shorts out and your system stops working. So let's go make a set of lines here, and then we'll end up with something that looks like this. Okay, so the next step in the process is to wrap the end of the lines using a small crimp tube and an eyelet. And you're going to need 4 crimp tubes and 4 eyelets. Now what I would normally do is just roll out a set of lines, have them measured to length, and have them on a reel. Now you're going to want at least a foot of excess on the lines per end. So that means if you want 60-foot lines, roll out 62 feet. That gives you a good foot of excess so that you can get all this, and then you can get the length of lines that you want. Now for the purposes of this video, I'm just doing a demo set of lines. This is just a short set. I'm going to so this is just for demo purposes. When you put the lines on your reel, leave at least 2 feet hanging out on both ends so that you can do the ends. And then once they're all completed, roll them back out and then put them back on the line nice like you normally would. Okay, so the first step, and you're going to do all 4 ends the same way. You're going to take this small, they're kind of hard to hang on to. You're going to take that tube, you're going to stick it over the end of the wire, put the wire through, now you want to have extra. So when you roll out a set of lines, make sure that you have enough extra, probably at least a good foot of extra wire on the ends, because you're gonna want extra, because you have to pull out extra. Now you're gonna go through the tube there, then you're gonna go back. You're going to double back and go back through the tube the same way you did the first time. So now it looks like this. So it goes through the tube, comes around, goes through the tube, comes back around. Now what you need to do is you need to get the eyelet in there. Now you're going to need this this part is what hooks up to the wire connector. And we'll get to that in a minute here. So this loop we need to tighten up. And so you practice first. But what I tend to do is I tend to push that down. And you pull that through so that it's kind of tightened up. Now that you're at this point, it's helpful to have a set of pliers where you can kind of hang on to stuff. We're going to put the eyelet. What I'm doing is I'm holding the crimp tube. And what you want to do is you want to get the eyelet so that so that the wire is going around the eyelet. Okay, when you have your loop here and you got some slack in there, put your eyelet in there and then pull on the main wire until it tightens up around the eyelet. So now we have the main wire here. This is our extra that's going to go to the electrical connector. It wraps around the eyelet and it's going through the tube. So we haven't crimped the tube yet, but that's coming next. Okay, now what you want to do is you just want to crimp that tube. Now even if you didn't crimp it, it still wouldn't give way because it's wrapped around. It's gone up and around this crimp tube, so even if you didn't crimp it, it still wouldn't fail. But you still want to crimp it. Okay, now we need to connect this wire to this wire. Now I haven't stripped these out yet, and I haven't stripped these out yet. Now this end of the nylon coated line still has this nylon coating, so we're going to take an X-Acto knife and we're going to strip off the section of nylon coating right here at the very end, and we're going to take this wire here. Now I'm only going to be using 2 of these 3 wires. I'm going to be using the white and the black, but not the red. So we're going to be modifying this wire here. Now, when it comes, when you need to buy your wire, it's nothing more than a servo extension cut in half, because you're going to need a male connector on one end of the lines and a female connector on the other end of the lines. So this is, you can just buy a servo connector, a servo extension, cut them in half, and you get both types. This is the female, this is the male. Okay, off camera, I have taken, what you'll notice here is I've taken the red wire that was in there. It's now gone. The black wire and the white wire has been stripped at the end here, so I got the wire exposed here, and it may not be real obvious, but this end of the nylon coating has been stripped with with a sharp blade. Now it's not really thick nylon coating, so you just take an X-Acto knife and scrape off the nylon coating right here, and then you have that. Okay, so we have our small little crimp tube, and we have the exposed wire from the flying line and the exposed wire from the electrical connector. And I'm just going to put this little tube here and it's not soldered or anything. It's a little bit kind of get a feel for it. Okay, so there we go. So now we have this line and this line are in contact with each other. Now the reason why I don't solder it, and I just do you do a crimp on that with a set of pliers, is because you may want to remove that electrical connector at some point. And if you do, then all you have to do is kind of re-squeeze this in a little differently, and you can get this guy off, take the wire off, and you still have this. So now what you got to do is you got to do the other one. Okay, so off camera I went ahead and finished up the other end, and then connected this opposite side. So now we have one end done, but we're going to do one more step here. Now it's got both connectors here. Now it's all connected, but at the flying site these wires get pulled and tugged, and so if you were to handle this at the flying site, this joint at the wire would eventually break. So what we learned was you take heat shrink tubing and we're going to put heat shrink tubing over that section of wire. Now this is kind of a sharp wire right here, so the heat shrink tubing kind of protects that from you from getting hit with a nice sharp wire. Now if you shrink that down, it keeps it, as you pull on it, it's no big deal. Now you can use whatever color you want, because at this it really doesn't matter. But on the next step we'll see that we have to get to the right wire here. So now once that is heat shrunk in place, it's done. So you have your female end here. Now the male end is going to be on the other end. You don't want to have two female connectors or two male connectors. You need a female and a male connector. Okay, now off camera I went ahead and shrunk the shrink tubing down, so you can see it's kind of wrapped itself around. You can see the little tube here, and it's nice and tight. So now as you pull on these wires at the flying field, it's gonna be durable and it's not gonna fail on you. Okay, so off camera I went ahead and did these end of the lines. Now this is the other end of the flying lines. And so you'll notice that this wire has the white wire and this wire has the black wire. Now the big question is, should I hook the white wire to this one or that one? And that's the question. Now I've kind of looped all these together. This is a demo set of lines. If it was a real set of lines, this would be on a line reel, but either way you cannot tell visually if this wire is this one or this one unless you use an ohm meter. What we're going to do is we're going to use an ohm meter and measure from this pin on the white wire to these two wires here and see where we get a short. And what you're looking for is, if you get an infinite ohmage, if it's not a complete circuit, then it's not the right wire. But if you get on the order of 100 ohms or somewhere in there, it's not 0 ohms, but it's going to be a value in the low hundreds. Okay, so off camera I went ahead and finished out the other end of the lines with the connectors. Now your lines are going to have a female connector on one end and a male connector on the other end. Now if your wingtip, if you have a female connector at the airplane, in other words, the airplane end of the lines hooks up to a female connector, you're going to want the male connector at the airplane end, and then the handle end of the lines is going to have a female connector. So in other words, your down the line electronic device, whether that be a servo driver or a modified transmitter or whatever it may be, it can plug into the end of the lines or it can plug in directly to the airplane. Either way, the type of connector you have at the airplane and then the type of connector you have at the handle end need to be the same type. Now, I was able to measure the ohmage across these two wires and figure out that this wire goes to the black and then this wire goes to the white. And that's just measuring the ohmage between the two wires. But now the real test of whether everything is working is to plug in your down the line electronic device. Now what I've got here is it's a servo tester that can actually also be used to, you can fly a control line model airplane for throttle control with one of these servo testers. It does work. You may have to repackage it because this is kind of clumsy to hang on to. So let's see here. Let's get all these separated. This is the single channel. It's what I call single channel setup because it's got a servo, a battery, and a very simple wire bundle. And then the servo tester plugs in, which is on your person when you're flying. That is you're hanging on to that. And that's on you. And so this, the ground and the signal coming out of this guy is being piped down these two lines. They're coming off the two lines, are going back into this connector and driving the servo, like so. But you want to test your system with the lines before you leave the house to make sure that you've got the wires set up correctly, or if there's a break in the connection. If there's a break in the connection, you have to figure out what's broken. Sometimes they break here. That's why we put the shrink tubing. Sometimes there's a break in the wires in the airplane or on your device. So this is the final test, if all that works. Okay, when you're all done, put your handle on the end of the lines that has the female connector. That way your down the line electronic device, whether it be a servo driver or a converted transmitter or whatever it may be, can plug in here or at the airplane. This end plugs into the airplane. It connects up to the airplane like it would normally. This connector plugs into the airplane. These lines are insulated. Now you notice that these lines are all wrapped up all with each other, and being nylon coated, they're insulated so it's not shorting out. So good luck, happy flying, land softly.